Hello my dear students. In this video we are going to discuss about balancing redox reactions. Balancing redox reactions. We are going to balance the redox reactions. So what is the meaning of redox reactions? A reaction in which both oxidation and reduction takes place. That is called redox reactions. So such type of reactions we are going to balance. There are two types. One is oxidation number method. Another one is ion electron method. Or that is called half reaction method. Half reaction method. So there are two types of balancing methods are there. First one is oxidation number method. Second type is ion electron method. Now in this video we are going to discuss about oxidation number method. Okay, so oxidation number method. Okay, so here, so the balancing of chemical reaction is very easy. I will say about 8 rules. I will explain about 8 rules. So follow the 8 rules. So you can easily balance the chemical equations. So in this method, I will write 8 steps. So take your notebook and copy the steps. But don't write these steps in the examinations. For your practice, I am writing all the steps. So during the balancing, follow the steps. Okay. So first write the equation as it is. No need to, don't balance anything. Just write the equation. Then after that, in step 1, this is step 1, assign oxidation number to the atoms. This is step 1. Step 2. So after writing the equation, first assign oxidation number to all atoms. Okay. Then second step, identify which atoms change in oxidation number. Change in oxidation number. Step 3. So step 1, assign oxidation number. Step 2, identify which atoms change in oxidation number. So you can easily identify which is oxidized and which is reduced. Then step 3, this is very important. Balance number of atoms. Balance number of atoms that change in oxidation number. Okay. After identifying oxidized and reduced atoms, in step 3 you are going to balance that particular atoms only. In step 4, this also very important, calculating the total change in oxidation number. You are going to calculate the total change in oxidation number for the oxidation and reduction. Okay, I am writing in shortcut. So total change in oxidation number for oxidation and reduction. So don't worry about this, I will explain during the balancing. Okay, just note down the steps. Then step 5, make the total increase in, so total increase in oxidation number to the total decrease by multiplying appropriate factors. Okay, so how much increased and how much decreased, the oxidation number, how much increased, how much decreased, that you are going to balance by multiplying appropriate factors. Then step 6, balance other elements. See here already balanced the elements which are oxidized and reduced. Here you are going to balance other elements other than oxygen and hydrogen. Then step 7, balance hydrogen and oxygen. Balance hydrogen and oxygen. Then the last step, check everything balanced. Check everything balances or balanced. Okay, so these are the 8 steps you have to apply during the balancing redox reactions. So this is called oxidation number method. You are going to use only by oxidation number. First step, assign oxidation number to all the atoms. In step 2, identify which atoms change in oxidation number. The third step is balance number of atoms that change in oxidation number. In step 4, total change in oxidation number for oxidation and reduction. In step 5, you are going to multiply appropriate factors to check the total change in increase and decrease oxidation numbers. In steps 6, balance other elements other than oxygen and hydrogen. In step 7, balance hydrogen and oxygen. And in step 8, you have to check everything is balanced. That's all. Okay, so I will explain and I will apply all these steps during the balancing. So I will show 1 or 2 examples, then you can easily follow that. All right, now this is the example. Equation is given as FeSO4 plus KMNO4 plus H2SO4 gives Fe2SO4 thrice plus MnSO4 plus K2SO4 plus H2O. This is the given equation. You are going to balance. See, normally we will balance how here Fe 2 atoms are here only 1 atom. So we will put 2 here, right? Then potassium K here 2K is there. So we will add 2 here. This is a normal balancing method. But here we are going to use oxidation number. With the help of oxidation number, we are going to balance. Okay. So in the first step, what I said, in the first step, assign oxidation number. So step 1, you are going to assign oxidation number. So see here, you can calculate separately. So I am writing on the top of the, so after writing, the equation, write the oxidation number on the top of the symbol. So Fe oxidation number is always plus 2. Oxygen, for one oxygen, that is minus 2. So 4 oxygen atoms are here, minus 8. So 4 into minus 2, minus 8. So remaining how much for sulfur? You can keep it 0, and if you calculate here, it will come plus 6. Now you see FeSO4, the total oxidation number will be 0. How? Plus 2 plus 6 plus 8 minus it will become 0. Correct? So that's all for Fe plus 2, sulfur plus 6, oxygen minus 8, because 4 oxygen atoms are here. Then here come to the KMnO4. This is potassium K, Mn manganese, oxygen. Potassium always plus 1, oxygen minus 2. So 4 oxygen atom minus 8. So minus 8 plus 1, you will get plus 7. Now you add all the numbers, you will get 0. Plus 1, plus 7, plus 8, minus it will be 0. Clear? Now hydrogen always plus 1 whenever it combines with non-metals. Sulfur non-metal, oxygen also non-metal. So there are two hydrogen atom. So it will become plus 2, and this is minus 8 because 4 oxygen atom, one oxygen atom is minus 2. So minus 8. So remaining plus 6. Minus 8 plus 2, you will get plus 6. So sulfur plus 6. So total, you add all the numbers, you will get 0. Clear? Now we have calculated all the reactants in all the elements and all the atoms. We have calculated the oxidation number. Okay. Now go to the product side. So reactant side, that's all. Now come to the product side. Product side, you see, for Fe here, before here I told plus 2. So there are 2 ion is there. Now before that you have to see, after calculating you have to add all the numbers, it has to come 0. Now for oxygen it is minus 8, then here it will come 3. So here put now see here sulfate SO4 it will come minus 2. So there are 3 SO4 are there, so it will come minus 6. Okay. So here 2 Fe atoms are here, it will come plus 6. So plus 6 minus 6, you will get 0. Here Mn, you don't know how much. For oxygen, that is minus 8. Then for sulfur, that is, it will become, manganese, it will be plus 2. So for sulfur it will be plus 6. So total 0. Then here potassium plus 2 because 2 potassium, 1 potassium, that is plus 1. Then here minus 8 because 4 oxygen atom, then plus 6. Then plus 2 minus 2. Clear? See here for such this kind of compound, suppose if it comes here, put for sulfate it is minus 6. Sulfate it is minus 2. So total 3 sulfate ions are there. So it will become minus 6. So of course here plus 6. Correct? So this is the way you have to calculate the oxidation number. Okay? Alright. So in step 1, assign oxidation number. In step 2, see oxidation number ON, that is oxidation number. So whenever you calculate the oxidation number, identify for single atoms. So step 2. So in step 2, we are going to identify the change in oxidation number. See here Fe is there. Okay, so for 1 Fe plus 2, then 1 sulfur plus 6, 1 oxygen, it will be minus 2. Okay, also look at here, potassium 1, Mn 7 plus 7, then here 1 oxygen, that is minus 2. Here for hydrogen, that is plus 1, for 1 hydrogen, this is minus 2. Here there are 2 Fe's there, so finally plus 3 for 1 Fe. Then here plus 1, then here minus 2, plus 1. Clear? So for one atom you have to find out. See here Fe, the oxidation number of Fe is plus 2. Then here you see it is plus 3. Fe here, that is one atom, that is plus 3. Fe equal plus 3. Okay. Then check others. Sulfur here plus 6. Then here also it will become plus 6. Here also plus 6. Here also plus 6. Okay. So sulfur doesn't change. There is no change in oxidation number for sulfur. Then here check for oxygen. Here this is minus 2. Here also minus 2. Here also it will be minus 2. Here also minus 2. Here also minus 2. So there is no change in for oxygen. Next come to potassium, plus 1 here. Here also plus 1. Okay. For one atom it will be plus 1. Then manganese, you check here. For one atom this is plus 7. Then here manganese, for one atom it is plus 2. So here some changes are there. So manganese, there is a change in oxidation number, that is plus 7. In the product side manganese, that is plus 2. Clear? Next one, oxygen we already calculated. Now hydrogen, this reactant side plus 1, then product side also plus 1. Then sulfur, oxygen, so we already checked. So that's all. So we have identified there are 2 atoms. It shows change in oxidation number. They are iron and manganese, Fe and manganese. Clear? Then step 3. In step 3, we are going to balance only the change in oxidation number atoms, only iron and manganese. Okay. So write the equation again. Fe SO4 plus KMNO4 plus H2SO4 Fe2 SO4 thrice plus Mn SO4 plus K2SO4 plus H2O. See, now you are going to balance only these atoms, only iron and manganese. Okay. So reactant side, how many ions are there? Only 1, but in product side 2 Fe. So here put 2. In the reactant side put 2 for this ion, for iron. Now iron is balanced. Here 2 iron, here also 2 Fe. Okay. Second one, there is manganese. This is the manganese. Now manganese, reactant side 1, product side 1. So it is balanced, already balanced. So you no need to put any number. So this is step 3. So in step 1, first assign oxidation number. In step 2, identify the change in oxidation number. Then third step, that is balance. You have to balance that atoms which shows change in oxidation number. See here Fe, put 2 here, then here put 2 here. So here already 2 atoms are here, so that you are adding 2 in the reactant side. Then manganese already here 1, here 1, so there is no need to balance. Clear? So now this week you learn only these 3 steps. Then the remaining steps we will discuss on the next video with two more examples. Okay, so now study about this step 1, step 2 and step 3. So we will discuss more detail with more examples in the next video. Okay students, so thank you very much.